All right, so let's revisit this question that I completely flubbed. All right, so we did a good job in class of two parts of this only, and by we I mean me. And that is that this is base function is the assign function. I'm going to do everything for that base function, which is what I was like doing entirely in my thing. Uh, and that's the family functions, right? Sine function. The domain of a sine function is negative infinity to infinity. Its range is -1 to 1, and its intercepts happen at every pi times an integer. So typically we'd write those things down as uh, pi times k comma 0, where k is an integer. And if we're going to do shorthand, we do this little z symbol. All right, but since we have these two transformations going on, this shift up and a vertical stretch, we're going to have some changes. And this is where I completely lost my mind and did not do things properly last time. So in this case, let's think about what happens with our transformations. Both of our transformations are happening to the y, right? They're both vertical transformations. So we don't have to worry about the x's. Even if we did, though, the x piece here is about our domain. And so the domain, if we shift negative infinity to infinity or stretch or shrink negative infinity to infinity, it would stay negative infinity to infinity. So domain is not going to have a problem regardless of what other stuff I tacked on to this. The range, though, we're going to have to change. And we're going to change it because it's about y, right? And we had all of our changes are happening to our y. We're going to follow the order of operations to change this, right? You have all these things that you do from trig. You're like, oh, yeah, that's an amplitude, right? That's changing to 3. We have that vertical shift of 2. But I'm going to show you that we don't need those trig-specific terms, that we can just say, okay, in terms of the order of operations with y, we're going to deal with the outside thing first. So the first thing we would do to transform this -1 to 1 is we would multiply it by the 3. Because it's a y, it gets changed just like our y's gets changed. And then we're going to deal with that plus 2. So we'll change this one more time to -1 to 5. This was the thing I was slow to do last time, right? We have these transformations. Now the intercepts, they don't work as nicely, especially for something like sine, because these are, if we shift this times 3 over 2, we now know a bunch of points, right? We have that midline points. If we're going through the midline at pi times k when at 2, at the midline of 2. But that's not very helpful. It's not an intercept anymore. So once we do that, we're going, oh, crap. Sorry, I should have done that in blue. We've completely changed our intercepts, and we don't have anything pretty in life anymore. So that's not an intercept. These are just random ass points. Still useful points for graphing, but still random ass points, and we would have to go do the actual work to find the intercepts. Finding the intercept for the y-intercept is not terrible, right? Y-intercept, we can set our x equal to 0. We would get f of 0 is equal to 3 times 0, cosine of 0, 0 plus 2. And so we've got one of them, 0, comma 2. The x-intercepts, unfortunately, they still exist. I only shifted my thing up 2, and so I still cross 0. So if I wanted to find my x-intercepts, I would have to actually do a trig equation, which we're not even really supposed to know yet because we do all of 104 again in like super speed when we get to like chapters 7 or 8, whenever, some way later chapter. So, but we would be doing this. 0 is equal to 3 times sine of x plus 2. So -2/3 is equal to sine of x. And then we would have all of these x's, or whenever our arc sine or sine inverse is equal to -2/3. And of course, we know there's an infinite number of solutions. We have to deal with that same exact issue. And here, thankfully, no period change, so it'll just be plus pi times k, but gross nonetheless. So that's the mathy piece on the side that I totally flubbed. Once we figured out that I had flubbed it, we did that domain restriction we just saw with x squared, right? We said, okay, we need a section where this is 1 to 1, and technically we like this non-decreasing. So we did this little domain restriction. We said our domain, if we want 1 to 1, is going to be only from -pi over 2 to pi over 2. because then my graph is a much fancier looking little graph. It is just this. Loop, 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 loop. Cool. And once we have that restriction, now we're allowed to do our work to find an inverse function. So we're going to go ahead, swap our x's and y's, solve. I like to have everything on the left side. And so we ended up with our inverse function was sine inverse or arcsine. You can use either notation, and Desmos recognizes either, of x minus 2 divided by 3. And again, you see a lot of patterns that was my hope was that we'd all finish our group's slides, and so we'd see all these patterns where if it was happening on the outside before, it's now on the inside, right? It was a times 3 and a plus 2 on the outside, and now we have a minus 2 and a divided by 3 on the inside. So there's lots of little checks that you can do to make sure everything is right. We also talked about, and we saw in the last example, you can check this by doing a composition. Ooh, that got a little funky. And making sure that it gives you out whatever you had as the input, or you can check this using the graph, because what should happen now, if we're putting this across that x is equal to 1 line, we should see something that looks like that on the other side. So that's what we're hoping to see when we go to Desmos and type all of this in. So anyways, sorry about all of this on the right. I came up with a question and didn't think through how all of that was going to work, and I didn't care about it. The part I cared about was domain restrictions, inverse functions, and checking that things were inverses. And so, yeah, that combined with no sleep and not being able to talk and do math at the same time, it's a problem. It's not one I've had before, but it's a problem right now. Yeah, all of that combined for some bad math. But anyways, hopefully that sets the record straight and gives you a little bit of help as to how those transformations impact these parts of the graph that we usually talk about. So when you start talking about our exponentials and our logs, those things with asymptotes, those shifts, it's all about what they impact. So if it's a horizontal asymptote about y, a shift up or down is going to impact that. Stretching it doesn't change anything, but a shift up or down might, right? Same thing with our, oh my god, my brain is broken. Oh, with our vertical asymptotes. You need to have a shift in terms of x that will change that or change your domain. So anyways, that's it. That's all of chapter 1, and then I'll get started on chapter 2 tomorrow.